Hi, welcome to another 4AC video. This round we look at quiz 4B, which we have just completed. And let's see what does the question wants. Now, this round we look at set B. Early on we have looked at set A. Now, set B requires us to look at this circuit where there are three parallel loads, load 1, load 2, and load 3. They are all connected to an AC supply, 230 volt, 50 Hertz. Now, what are we required to do? We are required to calculate the branch currents I1, I2, and I3. We next are required to calculate the real power and reactive power for each of the load 1, load 2, and load 3. And then we calculate the overall apparent power and the overall power factor. Finally, we are required to calculate the power factor correction capacitor, which is required to raise the power factor to unity. That means I want to put a capacitor across the so-called the incoming supply to correct the power factor to unity. Well, let's see how we tackle this question. Well, to answer this question, what I've done is to quickly sketch out this circuit again, and then we can look at it and refer to it. All right, the first thing I want to do is look at load number 1. Now, load number 1, because these are parallel, this whole voltage can be applied to all these three loads. So that makes it very easy for me to calculate the branch current. So I1, using Ohm's law, will be just E over the impedance of 1, right? So that will be 230 volt angle 0 degrees divided by 250 ohms, also 0 degrees. That will give me the current is 0.92, and the angle 0 degree ampere. So that's the first branch current. Now the second branch current, because the information given is slightly different, I need to do some extra calculation. Since the power factor given is 0.82, it means that the angle theta is cosine inverse of 0.82. That will give me an angle of 34.92 degrees. Now I2 can be calculated from S2 over E2. Oh, E, sorry. So that means I have 2600 angle 34.92 divided by 230 volt angle 0 degrees. That means the current is rather the conjugate current. The conjugate current will be 11.30 angle 34.92 degree amps. But since it's a conjugate, remember this complex power is E multiplied by I2 conjugate. So I2 conjugate is just the mirror image. Therefore, I2 is just 11.30 angle minus 34.92 degrees ampere. And finally, for load 3, I will have to calculate the Z3. Or maybe I just calculate it here and there. Z3 in complex form. Z3 in complex form will be 82.76 in the angle of minus 64.98 degrees ohms. So to calculate I3, I just need to do is E divided by Z3. That is 230 volt, 230 angle 0 volt divided by 82.76 at an angle of minus 64.98. That gives me a current of 2.78. 2.78 angle 64.98 degrees ampere. Right, so these are the 3 branch current that we have calculated. Okay, maybe I like to highlight this so that you can see it clearly. 1, 2, and 3. Alright, that's for part 1. Now we look at the real power or true power and the reactive power of each of these branches. So for load 1, the real power P1 can be calculated from I1 squared times R, which means 0.92 squared times 250 I square R. Right, that will give me a value of 211.6. 211.61. And the Q or Q1 will be 0 since there is no reactance there. 0 VAR. P2 can be calculated using the formula S cosine theta. That's 2600 times 0.82, and that will give me 2132 watts. 2132. Q2 similarly can be calculated for S sine theta, which is 2600 times the sine of 34 sine 34.92 degrees. That gives me 1488.32 VAR. And finally, P3 can be calculated using the I square R method as well. I3 square. Now this time the R is from here, the rectangular version of this number. That means I3 2.78 square times 35 ohms. That will give me just check it out, 2.78 square times 35, 270.49, 270.49 watts. Right, and the Q3 is I3 square, but this time is the X component, which happen to be negative. So take note. So negative is actually a capacitor there. So I will have 2.78 square times 75 ohm. 2.78 square times 75. That is 579.63. 579.63 VAR. Right, so this is what I have for all the individual power, true power and the reactive power. Now what we can do is make use of all this information and proceed on to the next part of this question, is one where I need to calculate the total apparent power. Now the total apparent power is actually given by the sum of all this real power, P1 plus P2 plus P3 plus J of the Q value, so Q1 plus Q2 plus Q3, noting that Q3 is actually negative because of the negative J here, right? So when I do that, I can add them up. So what I do is I get P1 211.6 plus 2132 plus 270.49. I will get 2614.09. So 2614.1 plus J. Now J, I have Q1 is 0, Q2 is 1488.32 minus, remember the minus, 579.6. That gives me 908.69. The whole thing, VA. That's in the rectangular form. So all I need to do now is to convert this into the polar form. Let me calculate the polar form. Polar form be 2614.1, 908.69. That will give me 2767.53. So that will be 2767.93. Sorry, from 53. Angle 19.168. 19.168 degrees VA. Okay, so that's my apparent power. Now, from this apparent power and angle 19.168, I can then calculate the power factor. Hence, continuing on, the overall power factor is the cos of 19.168 degree. Cos of 19.168. That gave me 0.9445, less than 0.945. 0.945. Lagging, right? Why lagging? Remember, lagging is because there's a plus J here, right? Plus J means it's inductive. Inductive means the current is lagging. The total current is lagging the total voltage. Okay. So that's the answer for part 3. Part 3 with the part 4. We want this. Let me draw the power triangle first. My power triangle will look something like this. This S, which is 2767.53 VA. The true power P is 2614.1 watts, and the reactive power Q is 908.69 VAR with an angle of 19.16 degrees. Now we want to introduce a capacitor into a circuit. But this is the total circuit that we have the Z here. We want to introduce a capacitor here such that I can improve the power factor to 1. Right, I need to introduce a capacitor here. So to do that, I want the new power factor is equal to cosine 0 degrees, because that will give me a power factor of 1. Now to do that means that I introduce a capacitor such that it will provide the reactive power which cancel out the current inductive power. In other words, my reactive power by this capacitor must be of the same value as the existing circuit's reactive power, which is Q, which is 908.69 VAR. But we know that QC is actually the E square over XC, which is here. Okay, so from this I can determine XC is equals to 230 volts square divided by 908.69. That will give me the reactance of 908.69, 58.215, 58.216 ohms. But we also know that Xc can be calculated by using this formula, 2 pi f C, where C is the value of the capacitance we want. So rearranging this formula will give me the capacitance to be 1 over 2 pi f, where f is the frequency of the supply voltage multiplied by Xc, which means equals to 1 over 2 pi 50 Hertz and 58.216 ohms. That will give me a capacitance of 50 divided by 216. Will give me a capacitance of 54.677. 54.677, which is close to 54.68 microfarad. Right, so that's the capacitance required to correct the power factor of this circuit to 1. Now, what's left is for me to identify my answer. This is my answer. This is my answer. And the earlier one. Right, so I hope you have learned something about power factor correction. And goodbye. Hi, welcome to another 4AC video. This time we look at a quiz, QUIZ4A set B that we have recently done. Now this quiz question goes as follows. A 230 volt 50 Hz supply is connected to three loads, load 1, load 2 and load 3, all with information given, and we are asked to calculate branch current I1, I2 and I3. Next, we are required to calculate the real power and reactive power of load 1, 2 and 3. And finally, we want to calculate the overall apparent power and determine the overall power factor. Finally, we want to determine a capacitor that we need to put across here in order to improve the power factor, the overall power factor to 1 unity. Let's see how we answer this question.